Recording ಆಗ್ತಾ ಇದೆ. Good morning. So am I audible?
Yes, sir.
So today we shall discuss some more problems on the duty and delta of irrigation water. Now here we have a problem, typical problem. So this problem we have discussed in the last class. What is the maximum or design discharge required in the canal? So next problem, the base period, intensity of irrigation and duty for various crops under a canal system are given in the table. So find the reservoir capacity if the canal losses are about 20% and the reservoir losses are 12%. Now here you have the various types of crops, wheat crop, sugarcane, cotton, rice and vegetable, and the corresponding base periods are given here in the column 2. And duty at the field for each crop has been given in hectare per cubic, and area under each crop is in hectares. The corresponding values are given. Now we have to calculate the reservoir capacity considering the canal losses as 20% and the reservoir losses as 12%. Now first we shall calculate the volume of water required for each crop. The volume of water required for each crop. Now one by one we shall calculate. So for wheat crop, the discharge required. What is the discharge required? So discharge is nothing but the area under the crop divided by the corresponding duty. So you get the discharge in cubics. And the volume of water required. The volume of water required is multiplied by the base period. So base period is in days. So you get the volume of water for each crop. So for wheat crop, it is 4,800 divided by 1,800 multiplied by the base period. Now, so it will be about 300 cubic day. So here discharge is in cubics. When you multiply it by base period, it becomes 320 cubic days. So similarly for sugarcane, the discharge required is the area under the crop divided by the corresponding duty, that is about 7 cubics, and the volume of water is about 2,520 cubic day. So because it requires more amount of water, since sugarcane is a perennial crop. Next for cotton crop, similarly the discharge required will be in cubics, that is area divided by the duty, and the volume of water will be, and the base period is 200 days. So hence, because cotton is a 8-month crop, so it is about 342 cubic days. Now the rice crop, the discharge required is area divided by the corresponding duty multiplied by the base period. So it will be about 426 cubic days. And for vegetable also, it is about 240 cubic days. Now, the total volume of water required on the field for all the crops. So add all these values, that is how many number of cubic days, that is about 3,848 cubic days. So when you add all this, the value will be about 3,848 cubic days. Now, we know the definition that 1 cubic day is nothing but 1 cubic of water flowing for the entire day. 1 cubic of water flowing for the entire day. So it is nothing but 8.6 hectare meter. So 1 cubic day is nothing but 8.64 hectare meter, and it is the quantity of water flowing for the whole day at the rate of 1 cubic. So now, hence this is the equation which tells that 1 cubic day is equal to 8.64 hectare meter. Now the volume of water required on the field will be, so we got it as 3,840 cubic days, that multiplied by 8.64, it will be in hectare meter, that is 33,300 hectare meter. Now we have to calculate the reservoir capacity. We have to calculate the reservoir capacity required if the canal losses are taken as 20% and the reservoir losses are taken as 12%. So now the volume of, now since the losses in the canal system is about 20% and the volume of water required at the head of the canal will be the total volume of water required multiplied by, that is 0.20 or 100 by 80, correct? 80%, it is 80%. That is this divided by 80 divided by 100. So it will be nothing but 0.2%. So hence the volume of water required at the head of the canal is 41,600 hectare meter. Now allowing 12% reservoir losses. The storage capacity of the reservoir required is 21,600 multiplied by 0.12 or 100 divided by 88. So it is about 47,300 hectare meter. So now the same problem can also be solved by another method. So we shall discuss that one. So here by calculating the volume of water required for each crop, then converting it to multiplying it by the corresponding base period. So I'll get the values in cubic days. So I can convert the values in the cubic days to hectare meter by multiplying by 8.64. Then considering the reservoir losses and canal losses, we can calculate the storage capacity of the reservoir. The same problem can be solved by another method. So now here you have the crops, the various crops, and the base period is given here. And the duty at the head of the field for each crop is given in hectares per cubic. So these are the values given. Now you can calculate the delta. Delta is nothing but the total depth of water, and we know the relation that delta is equal to 8.64 V by D. So thereby we get the total depth of water in meters. So that is the column 4 values are nothing but the total depth of water required in meters. So next we know the area in hectares. So the area grown for each crop is in hectares are given. So if you multiply delta multiplied by the area in hectares, so you'll get the volume of water in hectare meter, volume of water in hectare meter. Now you can see here, then you find the cumulative volume. What is the cumulative volume of water required? So it is about 33,290 hectare meter. So in this method, we got it as 33,000. So only about 10 hectare meter difference. That is 3,290 hectare meter. Now, we know the capacity factor for the canal. Capacity factor for the canal and also the losses in the reservoir losses. So the capacity factor of the canal is because the canal losses is about 20%. The canal losses is about 20%. Hence, the capacity factor of the canal will be about 80%, is 0.8. So multiplied by the reservoir losses as 12%, correct? So if you take out 12%, the remaining will be 0.88. So hence, the capacity of the reservoir required is about 47,300 hectare meter. So the same problem we can either solve by calculating the volume of water required and the total volume of water required for each crop. Then adding all this, then you will get the volume of water in hectare, cubic day. Then you have to convert it into hectare meter. Then considering the reservoir losses and canal losses, we can calculate the volume of water, total volume of water, or the reservoir capacity required. So the same problem can also be solved by this method. So next is one more problem. Find, here it is actually the field capacity. Find the field capacity of a soil for the following data. So the root zone depth of the soil is given, that is about 2 meters, and the existing water content in the soil is about 5%, and the density of soil is given, it is about 1.5 gram per centimeter cube, and the water applied to the soil, that is about 500 meter cube, and water loss due to evaporation is about 10%, and the area of the plot is about 100 square meter. So these are the given data from which you have to calculate the field capacity of the soil. Field capacity is nothing but it is the upper limit of the available moisture in the soil. So these things we have already discussed in the earlier classes, the classes and availability of moisture in soil. So the field capacity is nothing but it is the upper limit of the available moisture content. So now these are the given values. Now the total water applied to the soil is about 500 meter cube, and the water lost due to evaporation is about 10%. So the water effectively used in the soil is about 450 meter cube, because 10% is the evaporation losses. If you take out 10% from the total water supply, so the water beneficially used or stored in the soil is about 450 meter cube. So you have to convert this into grams by multiplying it by 10 power 6. Right? So So because the density of soil is given in gram per centimeter cube, so you have to convert the total water applied in grams. It is about 450 multiplied by 10 power 6 gram. Now the total dry weight of the soil and is the area is 1000 square meter. That is, it is 1000 meter square multiplied by the root zone depth of the soil is 2 meters multiplied by the density of the soil is 1.5 gram per centimeter cube. So here the nominator values are in meter and the denominator is in centimeter cube. So thereby if you multiply 1.5 into 10 power 6, so it will be converted into. Now we can calculate the percentage of water added. Percentage of water added is nothing but the total water that is stored in the soil, that is about 450 into 10 power 6 grams, divided by the total dry weight of the soil, multiplied by 100, because we'll be keeping the values in percentage. So it is about 15%. It is about 15%. Now, the net water content. The net water content will be, the existing water content is about 5% and the additional water content will be about 15%. So hence, the field capacity will be 20%. So like this, we can calculate the field capacity of the soil, knowing the values of densities of soil and the root zone depth and the area of the plot and whatever the existing water content and also the water supplied and also the water loss into evaporation. So next we have one more typical problem, that is about frequency of irrigation. Frequency of irrigation means it is nothing but after how many days will you supply water to the soil in order to ensure efficient irrigation of the given crop. So here we need to calculate the frequency of irrigation. Now here these are the data given. The field capacity of the soil is about 27% and the permanent wilting point is about 14%. This permanent wilting point is nothing but it is the lower limit of the available moisture content, and the density of soil is given 1.5 gram per centimeter cube, and the effective depth of root zone, it is about 75 centimeter or 0.75 meter, and the daily consumptive use of water for the crop is 11 millimeter. Now first you have to calculate the available moisture in the soil. So available moisture is nothing but it is the difference in moisture content between field capacity and the permanent wilting point. So field capacity is 27% and the permanent wilting point is 14%. Hence the available moisture is about 13%. Now we know that the readily available moisture. So it is about 75 to 80% of the available moisture. So hence the readily available moisture is, that is multiplying it 13 by 0.8, it is 10.4%. So that is nothing but it is 75 to 80% of the available moisture. Now the optimum moisture in the soil is the field capacity minus the readily available moisture. It is about 16.6%. Now when the irrigation is water is supplied, the moisture is raised from 16.6 to 27. 27 is the upper limit of the available moisture content or field capacity. So in any case, for optimum growth of the plant or a crop, the moisture should be in between the readily available moisture, that is the optimum moisture content, and the field capacity. So in this range, crop will have the optimum growth or maximum yield. Now, we know the equation, we have already derived this equation. The depth of water stored in the root zone of the crop during each watering, so that is gamma D. Gamma is density of soil, D is the depth, and gamma W is the unit weight of water. So that is my field capacity minus the optimum water content. Now, density of soil is given, that is 1.5 gram per centimeter cube, and the depth of the root zone is 75 centimeter or 0.75 meter. So that divided by the unit weight of water is 1. So thereby we will get the depth of water stored in the root zone is about 0.117 meter or 11.7 centimeter. Now the depth of water available for evapotranspiration requirement is about 11.7 centimeter. Now We know the daily consumptive use of water. That is, daily consumptive use of water is given here. You can see here, daily consumptive use of water for the given crop is 11 millimeter or 1.1 centimeter. So now the daily consumptive use is 1.1. So the water frequency required is nothing but the depth of water stored in the root zone divided by the daily consumptive use, that is 10 days. So hence water should be applied after every 10 days. So these types of problems also we may have to find the frequency of irrigation. That means after how many days you require to give fresh doses of irrigation water to the crop in order to bring the moisture content to its field capacity. Now this is one more typical of the previous one. Here also, so here only thing is the depth of water for irrigation. That is the depth of water stored in the root zone of the crop is calculated. Then the frequency of irrigation. Frequency of irrigation there is about 11.2 centimeters. So the other things are same here. The water application efficiency is given, that is about 75%. Determine the water depth required to be applied in the field. So it is almost similar to the previous problem. So this completes module 4. So tomorrow I will start the last module, that is 5th module. Now I will allow you to mark your attendance. Now you can mark your attendance in the chat box. Anyway, I will share these notes to your WhatsApp group, so you can go through these problems. So tomorrow I will start a new chapter, new module, that is 5th module, the last one. So you may require another 5 to 6 hours to complete the last module. So in the meantime, before second test, I will be giving one more assignment. I hope all of you have submitted the first assignment in Google Classroom. Again, on Monday, I will be giving one more assignment, including the model 3 and model 4. So before the commencement of the second test. And also I will start the new chapter tomorrow. So now you can mark your attendance in the chat box. I will be ending the session. Kavya case, are you there? Simply log in. Kavya case. Prabal Shetty.
Yes, sir.
Vilas.
Yes, sir.
Anushayan.
Yes, sir.
Abhijit.
Yes, sir.
Chaitra.
Yes, sir.
Kavya. Chaitra Evi.
Yes, sir.
Kavya.
Yes, sir.
Madhumita. Madhumita BM.
Yes, sir.
Rajinath Ji.
Yes, sir.
Manoj. Manoj. Mr. Manoj. Nitya P.
Yes, sir.
Yes, sir.
Pranita A. Shetty.
Yes, sir.
Ranjita S. R.
Yes, sir.
Ritu S. M.
Yes, sir.
Sahana M. S.
Yes, sir.
Sampath.
Yes, sir.
Sandeep. Sandeep H. S. Is not there. Sanjana D.
Present, sir.
Okay. So all of you have marked your attendance in the chat box. I could able to see only 11 members have marked. What about others? See, please stay logged in. Don't log out. So I'll be ending the session. So we shall meet tomorrow. End the meeting now.